Okay, so we are at the proof portion, and this is the second part of Cpctc, which is corresponding parts of congruent triangles are congruent. What we're given is J is the midpoint of Km and NL. So Km is this segment here. And let's remember, of course, that we are dealing in segments here. Okay? And so what we've got is J is the midpoint. And so what I am going to do is I'm going to go ahead and mark this diagram reflecting that information. And so what that means is this Km here is cut in half, but also NL is cut in half. I don't know whether they are the same. I don't know if Kj is congruent to Nj. So what I'm going to do is I'm going to mark them like this. Now, we want to prove that KL is parallel to MN. How do we do this? Well, I think it's best to think about it in terms of the context of the lesson. We're talking about Cpctc, and so what we're going to try to do is we are going to try to show that parts of this upper triangle here, and what I'm going to do is label it 1 and label this one 2, that parts of 1 and 2 go together in such a way that we can prove something about the angles. Okay, so let's try this. I'm going to label this statements, and reasons are going to be over here. Put a line down the middle. First, I am going to try to say that Kj, the segment, is congruent to Jm, and also I'm going to say Nj is congruent to Jl, and both of these are going to be by the definition of midpoint. Okay? And so I've marked that already, definition of midpoint. So that's, given a definition of midpoint. So let's see. If I'm going to try to prove that these two triangles, 1 and 2, are congruent, I have a side and a side. Between them just happens to be an angle. It's not really a coincidence that they have crossing lines here, because what I'm going to do is I'm going to say angle KJL is congruent to angle NJM. Because what I have here, if I can mark this, what I have here is something that tells me, yeah, these are congruent because they are vertical angles. Okay, so those are vertical angles. Now what I have is this. I can say that triangle KJL is congruent to triangle NJM because I have a side, an angle, and a side congruent to a side, an angle, and a side. Okay? So I've got KJL. Actually, and this should be, I did that incorrectly. I flipped these two. I've got KJL, and notice K to J is this segment here, so this should really go M to J to N. Okay, so it goes K, J, L, so 1, angle 2, so this should go 1, angle 2. So this is M, J, N. And this is going to be by side, angle, side, because it's a side, an angle, and a side, congruent to a side, an angle, and a side. Okay? So that's how this goes. What that means then is this, and I'm going to mark these up in such a way so you can see this. That means that angle K goes with angle M. That means that angle L, marked with 3 arcs, goes with angle N. Okay? That means that this side up here, marked with 3 arcs, goes with this side here. How does this help us? Because what I can say now is I can say that this will serve as my transversal for these two lines here, for NM and KL. Well, because angle LKJ, so LKJ, is congruent to angle, so LKJ, to angle N MJ. So this angle here is congruent to this angle here. Being very careful to keep my letters straight. So LKJ is congruent to NMJ. Because those angles are congruent, that's Cpctc. Because I proved that these triangles are congruent, so these corresponding parts of congruent triangles are congruent. How does that help me? Well, now I can say that KL is parallel to NM because that's the alternate interior angles converse. Okay? Alternate interior angles here are congruent, so that means that these lines must be parallel. And I couldn't say that they were parallel because I couldn't know anything about the angles until I proved that the triangles were congruent. So that's how that works. Let's go down here. This is one in the coordinate plane, and this going in the coordinate plane is particularly useful if we're trying to do stuff on like ACT or if we're doing anything in like graphical drawing programs. And so what we are going to prove is that we're going to use Cpctc and show that these triangles are congruent. Well, our plan is this. We're going to use side, 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 and distance formula to say that the sides are congruent. So what we need to do is figure out the sides. So we need the length of AC. We are also going to need, I'm going to just list the lengths that we need. We need AC, we need CB, we need AB. We also need to show that those are congruent too. So AC is going to go with DF, so AC goes with DF, and I don't have F on here. I actually mislabeled this one. This should be F down here. Okay, so AC goes with DF. CB goes with FE, not iron for those of you who are chemists out there. And AB goes with DE. Okay, so let's find AC. AC, and up top here I'm going to write out the distance formula. Some of you are remembering this on your own. D is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's plug this in. A and C here. So I'm going to go 2 minus 1 squared plus, and I did 2 minus 1, so I'm going to do 3 minus 0 squared. So that's going to be 1 squared plus 3 squared, square root, is equal to the square root of 10. It doesn't particularly matter that that is a square root. I'll just leave it like this. So I'm comparing that to DF, so I'm going to put DF down here. And I'll say D is -4, so I'm going to have -4 minus a -1. It's going to be squared plus -1 minus a -2 squared. A little bit trickier here. So this is going to be -3 squared, all under the square root, remember. And -1 minus a -2 would be plus 2, so that's 1. So this is also going to be square root of 10. So far, these check out. Those are good to go. Let's check the next two. Okay, I'm going to have to start writing a little bit smaller. CB. CB is square root of 5 minus 1. Remember, the order doesn't particularly matter. You just have to keep it the same. 5 minus 1 and -1 minus 0 squared. So this is going to be equal to square root of 16 plus 1 is square root of 17. We're going to compare that to FE, which is going to give us -1 minus 0 squared and -2 minus 2 squared. It's going to give us 1 squared plus 4 -4 squared is equal to square root of 17. So it's the same. So these two check out also. I'm going to have to write really small for this one. AB. is equal to the square root of 5 minus 2. And guys, I'm just picking an easy way to do this. I'm doing 5 minus 2 because it's easy for me. And then negative 1 minus 3, which is going to give us 3 squared plus negative 4 squared. So it's going to be square root of 25 equals 5. Okay? I'll scroll down a little bit. I want to keep those points up there. DE. DE is going to be square root of negative 4 minus 0 squared plus negative 1 minus 2 squared. It's looking pretty good. This is going to be 16 square root of 16 plus 9 is equal to square root of 25 is equal to 5. Not 0, 5. So these check out also. So what we can say is, by side, using distance formula, triangle ABC is congruent to triangle DEF. What does that help us do? Well, what we want to prove is something about the angles. And so we proved that the triangles were congruent. So what that means for us is that because ABC, this angle here, and DEF, this angle here, are Cpctc, we can say that angle ABC is congruent to angle DEF by Cpctc. That's what's important, guys. We looked back, saw what we wanted, and got it there. That's using the distance formula. Thanks for watching, guys. We'll see you next time.